Today we are going to discuss about one of the very initial and important phase of any data analytic steps. So that is exploratory data analysis. So what is EDA? What is exploratory data analysis? It is nothing but an attempt to explore the data in terms of the business objective or the problem statement that we are planning to solve. We need to understand the data that is given to us is relevant enough and good enough to us to proceed ahead to analysis and achieve the business objective and achieve the results. So we try to achieve the data, we try to get information from the data, we try to get insights from the data using the statistics, visualization and non-visualization techniques. So I can say here EDA as such nothing but the digging the gold or digging the insights from the data mine. So when we talk about the EDA, what all we expect, right? We want to describe the data. We see what all the relevant features that all given to us for the business perspective. How many observations have been given? We check each features, what is the relevance of it from the business perspective or the problem perspective objective. And then we then go and check the quality of the data. It's good enough to us to proceed with the analysis or not. Even we also check whether we have enough data for the business problem, uh, which is we are planning to solve. And then further, we try to seek the insights, understand the current business situation by using the data visualization technique. And then we get as the phase, that is the data preparation phase. Then we try to prepare the data and then keep it ready for applying the machine learning techniques or productive modeling techniques that we want to apply and uh, in apply on the data in order to achieve the business objective. Okay. So, so, so what we do, we have this structured approach that we would take for an EDA perspective. So let's take an example of a problem where we are trying to analyze a customer behavior where the claims are made by a or for a car insurance. So insurance company wants us to understand the behavior and let us know which are probable fraudulent claim that are requested by the company or customer or for the company. Okay, so we expected here to do the analysis. So obvious the claim related data like is the claim has been made, when was the claim made, what was for, was the claim made at the right time, the feature difference between the notification and the accident is not too much, and then we know the customer is genuine customer or not. Additionally, to this claim related information, we also want to like relay other information like uh, uh, dem geographical information, the customer information, even customer is with us, means with a company from uh, what time or not. So We also want to know how long the customer has been with the company. So all will be the relevant related features we need in order to do for our analysis of the fraudulent claim. Then further, we need to check the quality of the data. Usually when we make a claim, we fill the form manually. So to explain this, I can say there is a possibility that data operator can miss the data or some features which are very mandatory. Those are given by the customer, but the some features which are not mandatory, which are not given by the customer. So in that case, there will be a missing data. There can be a possibility the mistakes are done by the data operator. So which actually led to us to the bad data or the missing data. So we need to treat such a data to ensure that it is having a good quality. So additionally, we also check the importance of the feature which respect to business problem perspective. Like if the claim is for the particular product, so we should ensure we have all the information related to that particular product. So next we move on the inside of our data. To get the visualization technique, we have several graph and plots that are available for us to understand the relationship between the data. Know which data play an important role from our study perspective. So we make use of the different plots and graphs that are available to us to seek the insight. And at the end of this, we actually tried and get the current business situation. So final step is data preparation. There are many machine learning techniques which have some kind of a prerequisite. So post the analysis of the data, we try to prepare the data based on the machine learning techniques that we plan to apply as the data that achieve the results. So this is the actually structured approach to achieve the EDA effectively. So first step is what? Describe the data. Then we pre-processing that data. Then we try to understand the current business situation using the data visualization. And then finally we go for the data preparation where we generate or create the models to get and achieve the results. So let's look at the first aspects of it, that is a description of the data. Okay. So when we talk about the description of data, first and foremost, we understand the problem statement and the business objective. So what is it we want to achieve once we have clarification what exactly is the business deal? We try and check the data that is given to us. From the data perspective, first we identify dimensions of the data. We get the summary of the data. We look at the data in terms of the scope. For example, if we are working on the cricket data and we are expected to predict a win or loss of an one day international match. So the scope of the data could be all the cricket matches that happen in the 20th century going behind. To this 20th century may not be a very good idea because the situation and technology that was available in the past was not as good as it is available today. So check on the relevance of your data. Also the quantum of your data if is very important. If we are expected to identify fraudulent claims and non-fraudulent claims, and we have that data from the past, check if your data has enough information from both the categories. If there is only one or two fraudulent case, we may not able to do the justice in terms of the identify the behavior. Further, we understanding the feature. So if by default the business does not provide the data dictionary, uh, a data dictionary, nothing but a list of the field along with the description and meaning and the validation maybe that have been provided each of the feature. So this expected from the business who is providing the data, but if it is not provided, then it is recommended that prepare the data dictionary to understand each of the feature well, to know the meaning, to know the value. It is whole. What should be the data type of each of the feature? So this would help us to validate our data and ensure that the quality of our data is good enough to proceed further with our analysis. Further, by nothing, our statistic techniques try to identify the central tendency and distribution of the data. When we talk about the numerical field, central tendency would do correspond to your mean, median, mode, and we also try to understand the distribution and the on the shape of the data of each of the continuous variable with the help of our standard deviation. Also, if we observe the mean and median to be very near to each other, we know that the particular continuous feature and more or less is a normal distribution, right? Further, for the categorical variable, we try to identify the frequency of each of the categorical levels within the categorical variables. So, central tendency here would be the categorical level, which has higher frequency, and the distribution would how it is spread across the categorical level. So we understand what our data really contains. Further, once we have understood and we have summarized our data, we move as to proceed process called the data processing. So I hope you understood the how what is exactly to describe the data. So here we try to understand the problem statement. We try to understand the scope of our data, the time relevance of the data, quantum of our data, what all the features are given. The features are categorical, numerical. We understand the each feature, how it is going to help us uh, in our insights, and then we try to proceed with the further steps. So next step is data processing mm, step. So where we further digging into the quality of a data, as we understand data uh, is always means we understand that data, the real time data is always having the some noise. We need to be attentive and understanding each of the feature, knowing what value it can hold, and try as find out each of the feature holding the right value or not. So what is the possibility of the means possibility of a bad data, which we discuss about that data operator did not have the information and might have entered the special characters, so that can be a bad data. So other aspects are missing value. I don't have the information, so I entry has not been made. So data shows the blank values. Further, there may be anomalies. So here, domain knowledge really helps. There will be some business rule associated with each of the feature. If we are looking at the claim data for the particular product and expecting that the data corresponding to only that product and it's not a mixture of other product, so business rules or business understanding with the help with help us if there are any anomalies in the data, and if we need to check for any validation across the each of the feature. So here the obvious the business rules help us to understand what kind of anomalies are there, and how can we can impute those values, or we can use the rules to impute those value. So finally, not so uh, finally not so the useful data. So there is a possibility that some features may not be useful for us in terms of a data analysis. So it is a good idea to drop them or remove them and proceed with an analysis, as they are not going to give us any value in the digging the further insights. Okay, so get into this in a detail. We'll let's how we will find out about the bad values. If we are looking at the numerical fields, first of all, we will check the data type. If the data type of a numerical field is not as a float or integer type, it is an indication that there is a some bad data in it. So maybe a character or special character has been used in particular feature. So that's an indication which we have to be aware of, and we need to treat it. Further, in case of categorical fields, we try to see each of the categorical levels and the frequencies. While we look at the categorical levels, we will know whether there is a bad data involved in it to give an uh, in it. So give an example, then salary amount, we expect it to be a float kind of a data type. If you observe while the load your data on into the tool, it is not been identified as a float data type, but more of the string data type or an object data type. So it's an indication that the salary amount have some bad values, which has to be clear that, or which has to be treated that there. So other aspect I can say, age data type is proper, it is integer or float, but while you look at the range of the age field, you see it the ranges is from 0 to 60. So zero age is not something that would be probable, especially possible, or especially in business kind of a scenario, right? So where we are look at the claims, and there are multiple examples. So maybe the data is not available and the age has been entered as a 0. So be aware of the quality of a data. Try into the digging of each of the feature to see if the information that is provided us to the good enough to proceeding with the analysis and claim the data. Okay. Next is we'll go for the anomalies. So anomalies, as we discussed, so there are chances that there will be anomalies in your data. There will be a noise in our data. It is not following a business rule. For example, a financial kind of a scenario. If you have a loan data, you will come across some ratios, net loan to the value ratio or fixed obligation to the income ratio, and it would be expected that they are within the particular range. So if your data has a value which is beyond particular range, then there is a problem which we need to clean up. Okay. So further, not so useful data. Uh, so duplicate rows means in case there are duplicate rows, the entire rows of information, all the features having the same value across the different rows doesn't help us. It is not something that will really be varying over the observations. If we try to carry such a data for further machine learning processing, it may happen algorithm that we use, we will get the bias towards. So this information, so if duplicates record which are present are not relevant or not genuine, are the sum across all the features in the data, we try and remove the duplicates, and then we retain only the observation that ratios from the data that apart from this. So we will also observe some features where the some information given across all the observation observation. For example, there is a product type, and all the observation that I have call out a product A. So this particular feature does not lead to any variation or does not help to analyze in my analysis. So maybe later, based on the variation, it has or it has one of the value which is throughout. So that so not a very useful field. So in that case of the numerical field, if you do a summary, so that mean, median, max, mean, everything is the same value, which an indication that this is a zero variance fill, which is not useful for our analysis process. So additionally, these features, which some features like unique values across the observations, like our index field or maybe customer field or any other field, may also be something that not very useful to us. So we can go ahead and drop it. Also, in your data, if any of the feature in your data, you have more than the 25 to 30% data is missing values. So it is recommended that you drop that particular feature, uh, because the reason being, if we try to treat them or we try to impute them with the some value, it may change the data to a great extent, which in turn the change the business situation, not be the real case scenario. So we suggest here there are too many missing values. So go ahead and drop those features before you go with the analysis. So at this stage, there is also an important aspect called as the feature engineering. Sometimes the features that have been given to you may not speak much by themselves, and based on that domain knowledge, it may be a good idea to derive the features from the existing features. For example, if you have a data related to the defect analysis, and you have features called the defect, which contains number of defects within that particular column. And the second features may be a size of the task. That has been done. So deriving the feature in the form of the ratio, that is the defect per size of the project, would have more relevance other than the having just number of defects and just the size of the project. So based on the business objective or the problem statement you are planning to solve, you may choose to derive of the feature called the defect per unit size, and we and use that feature in your analysis rather than just the defect and the project size feature, and proceed ahead. You will find such a situation in many of the financial related projects. So try and get the feature such that they are strong enough and helping in your analysis to derive the good insight from the data, and at the from the data, and at the end of the EDA, we want to be very confident about the data. We want to ensure that it is indeed going to help us moving forward with our analysis and models in our machine learning process. So let's move to the next part now, to the um, pre-processing with the Python tool. So let's discuss about the real life problem, and we understand all these structure approach using the example. Okay.